All right, hi, Chargers. This is Mrs. Boyd here with Geometry B, section 10.5, talking about tangents today. So at the top here, you can see a tangent in line within the same plane as the circle that intersects the circle in exactly one point called the point of tangency. In the figure to your right here, the line here, AB, is tangent to circle C at point A, the point of tangency. So that means that segment AB and ray AB are also tangents. Common tangent is a tangent that is between two circles in the same plane. So line L is a tangent between F and G. And line L is another common tangent between circle F and G. So we're going to do some looking at some of our own figures here and see if these have tangents, common tangents, and if so, how many. Well, if we look at the letter A, we can put, let's see if I can figure out how to put a line on here without having to draw a straight line. Nope. So we can put a tangent here that touches each of these circles in one spot, and we can put a tangent, a common tangent here that touches each of those circles in one place. So that is two common tangents. If we look at the next set at letter B, there seems to be several more places where we can make common tangents. Kind of the same idea from before. You can do one on top here and another one on bottom. We can also draw some tangents, some common tangency lines. Oop, that one went very good, like this. And then a little bit like that. Mine are not very great. Nonetheless, that makes 4 common tangents. Try the next 2 on your own. Tell me how many common tangents. Start with letter C. All right, letter C. Let's scroll down here. I can see a few tangents, common tangents between these two circles. I can see one really easily at the point where they meet there in the center. I can see another one across the top of each of them. And another one across, oh, that one was awful, I'm sorry, across the bottom of each of them. So that's 3 common tangents. Oh, that's the worst writing. All right, pause and see the next one and see how many you can find. All right, letter D. Looks like we've only got 1 common tangent, and it's at that point where those 2 circles meet. So letter D has 1 common tangent. So far, so good. Moving on. Woo, whoa, so sorry. Gosh. All right, theorem 10.10. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of the tangency. So we've got a line L here that goes across the bottom of circle S, and it's tangent to circle S only if ST is perpendicular to L. So let's look at what that means for the next couple problems. We've got line JL, that's a radius of J, and we want to know if KL is tangent to J, and we want to justify our answer. So we need to see if JKL is a right triangle. So to do that, we need to use Pythagorean theorem and say that if it is a right triangle, then 15 squared plus 8 squared should equal 9 squared. So let me find my calculator here. We know that 15 squared is 225. And 8 squared is 64. Oh, junk. I made a mistake. J, and I'm going to call this point S. JS is another radius. And if JL is 8, JS is also 8. So that means that this is not going to be equal to 9 squared. This is going to be equal to 9 plus 8 squared, or 17 squared. So that means 225 plus 64 should equal 17 squared, which is 289. So 225 plus 64 does happen to be 289, which does match 289. So that means JKL is a right triangle, and J or KL is a tangent to circle J. So line KL is tangent to circle J. All right, try the next one on your own. I hope you can keep from making the mistakes that I did. Jeez. All right, let's move on down here. We want to know if JH is tangent to F. So that means we have this circle. And we want to see if they are tangent. So let's learn from our last mistakes. We know that FG is 6, so that means this radius here must also be 6. So if HG is a tangent, that means that G angle needs to be a right angle. So we know the Pythagorean theorem should work and say that 8 squared plus 6 squared should equal, question mark, 12 plus 6 is 18 squared. So 8 squared is 64 plus 36. And we know from before that 18 squared is 324. 64 and 36 is 100, and that does not equal 324. So GH, line GH, is not a tangent to circle F because it's not a right triangle. So we can also use what we know about right triangles and tangents to find some missing values. We're told in this one that JH is tangent to circle G. So that means this is a right angle. So we want to find the value of X. I don't know why that says so. GHJ is a right triangle. So we want to, not that, find X. So if we know that the X plus 8 is the hypotenuse, and X squared plus 12 squared should equal X plus 8 squared. So let's square some things. X squared is going to stay X squared plus 144. Now I need you to reach back into your algebra knowledge here and see that X plus 8 squared is really X plus 8 times X plus 8. We use the FOIL method. Oh, we're really drawing back into the archives. FOIL method says that we take first times first, so X times X is X squared. X times 8 is plus 8X. 8 times X is plus 8X. And 8 times 8 is plus 64. Let me draw out for you more exactly how I found that. X plus 8 and X plus 8. So we do first times first and get X squared. 2 outside terms plus 8X. 2 inside terms plus 8X. And the 2 last terms plus 64. Okay, it's a quick review there. Now, we can combine some like terms on the right. The left will stay the same. We've got x squared plus 16x plus 64. So I want to get all the like terms together. So I'm going to subtract x squared from each side. They cancel on the right and they cancel on the left. Okay, so I'm going to move on. I'm going to subtract 64 from each side. And I get 80 equals 16x. And divide by 16 on each side and get x is 5. Ta-da! It took a little doing, but we totally did it. Let's do another one. We want to find x here, and we're going to assume that BC in this case is tangent. So that means this has got to be a right triangle. 17 is our hypotenuse. That means 17 squared is going to equal the sum of the other two sides squared. So 14 squared plus x squared. So 17 squared is 289. And that's going to equal 14 squared, which is 196, plus x squared. Well, we want to get x squared all alone. So let's subtract 196 from each side. And we get 93 is x squared. Remember, we've learned so far before that the way to get rid of the square is to square root each side. And that gives us x is the square root of 93. You can leave it like that, or you could take the square root of 93 and see that x is going to be equal to about 9.64. All right. Try the next one on your own. It's a little bit different, but I think you can do it. All right, let's do it. We've got 2 plus x is our hypotenuse if QS is the tangent. So that squared is going to equal 4 squared plus QR is going to be x again. So plus x squared. So let's write 2 plus x like we did above, so we can use the FOIL method. 4 squared is 16, and x squared stays x squared. Now we multiply. 4 plus 2x plus 2x plus x squared is 16 plus x squared. Combine like terms on the right. 4 plus 4x plus x squared is 16 plus x squared. Now we have to get the like terms together. The x squareds cancel. And then subtract 4 from each side and get 4x is 12. Divide by 4 and get x is 3. Hooray! We totally did it. Let's keep on keeping on. Theorem 10.11, if two segments from the same exterior point, like point B in this case, are tangent to a circle, then they are congruent. So AB and BC are both tangent, so that means they are congruent. They're congruent to this, they're tangent to the same circle. Oh boy. So if we look down here at number 6, if AB and CB are both tangent, they are congruent. So that means we can say that x plus 15 is equal to 2x minus 5. Now we have to find the value of x. So I'm going to subtract x from each side and get 15 equals x minus 5. And then add 5 and add 5 and get x is 20. Pretty straightforward, right? Let's try this one on your own. You can totally do it. Ready, set, go. Okay, here we go. We've got QR and RS are both tangent. So that means they are congruent. And we can set them equal to each other. So we subtract 8. And we get 3x equals 18. And x is 6. Try the next one. Keep it going. All right, these are both tangents, so we set them equal to each other. 2x plus 9 equals 3x plus 6. Let's subtract 2x. We got 9 equals x plus 6, and then subtract 6. So 3 equals x. Very nice. All right, almost done. Now we're going to look at polygons that are circumscribed. Polygons are circumscribed about a circle if every side of the polygon is tangent to the circle. So we look at the ones on the left, and we've got a triangle here, and each side of the triangle is circumscribed about the polygon because each side of the triangle is tangent. Circumscribed means all the sides are tangent, and this is the same thing. These are not circumscribed. They're not around the outside all the way. This rectangle is around the outside of the circle, but we've got one side here that is not a tangent. And the last hexagon here, not all the sides are touching. So we have to be particular about what we say is a circumscribed polygon. We see that graphic designers giving directions to create a larger version of the triangular logo shown. So if ABC is circumscribed about circle G, find the perimeter. We know parts of the perimeter, but we want to know more. So since triangle ABC is circumscribed about circle G, AE, and AD are tangent to circle G, as are BE and BF, and CD and CF. So since angle A here, these are both tangents to this circle, that means they're going to be equivalent or congruent. So if AD is 8, AE has to also equal 8. If AB is 15, so if EB is 7, that means that BF is also 7. So if this whole thing, if all of CB is 10 and BF is 7, all we left is 3 for CF. So CD is left for 3 as well. So all I have to do is add all these parts together. 8 plus 8 plus 7 plus 7 plus 3 plus 3. And we get 10, 20, and 16 is 36. So 36 feet is the perimeter around. Same idea. Try the next one on your very own. So now we're told that the perimeter is 18 units. So that means we have to find what x is. Same idea as before. If CR and DR are from the same angle and they're both tangents, that means they're congruent. So CR is 3, just like DR, and AS is 3, so SD must also be 3. So we add all the, oh, here we go. And then we've got BT is going to be X as well, and BU is also X. So we've got 1, 2, 3, 4 X's plus 6 plus 6 equals 18. So we can simplify this to 4x plus 12 is 18. And subtract 12 from each side and get 4x is 6. And then divide by 4 and get x is 6 over 4 or 3 over 2 or 1.5. Any of those will work. All right, kiddos, I hope this helps. I hope you know exactly what you're doing and getting into. Let me know if you need any help. Best of luck.